Hey everyone, welcome to ThetaWave. I'm Ryan Reed, AI engineer and musician and songwriter. I'm here with my co-host, Jacob Holland. Jacob, what have we got for today?
All right, so today, this is the first ever ThetaWave podcast recording. So what this is going to be, it's going to be a test run. We're going to see how we like the angles, what we need to change, what we like, different things of the sorts, while we talk about some pretty fascinating topics, I think everyone's going to enjoy.
I know I enjoy the stuff that we talk about. And that was
Exactly.
kind of the whole inspiration behind this thing was we were like, dude, these topics are so fascinating. Like, how could other people not find this interesting?
Exactly. And so since we are so knowledgeable about all of these topics, we are going to let y'all hear our discussions about different things, such as different nootropics, some machine learning topics as well, and maybe even some philosophy today. All right.
Yeah.
So, okay. So real quick, I have a question for you. So I'm sure you're aware of the black box of AI that kind of holds that mystery to it.
What black box?
It's the binary kind of code that's unintelligible, that no one really knows what exactly. It's not decipherable within the confines of that AI system.
Okay. I'll save my thought on that for later, but go ahead and continue your question.
What I'm curious about is I like, for consciousness especially, that kind of integrated information theory, where we have kind of these lower level complex systems creating kind of a meta system that is not exactly explainable with each particular part of the system, but rather create something as a whole, a like meta information, if you will. So what I was curious about is is that kind of the same with AI? Is that we have kind of these lower level systems or this information getting trained, and it's not necessarily intelligible from the point of each specific part, but rather it creates something that would be seen as kind of a meta awareness, technologically speaking.
Um, so strictly speaking, no, not
No.
really.
Okay.
We are capable of diagnosing and dissecting our machine learning models down to the very like neurons and their weights, and so we do have the ability to see how everything is fitting together, and kind of the parts that each section or individual neuron plays in the whole. Um, but that's all in the form of like mathematics, and so oftentimes it gets a little it does get a little hairy trying to separate in like individual parts of a model out from the rest of it. Like, so the way that we typically design them is in layers that each have different functions, and different parameters within those layers that get tuned or trained. And usually each of those layers is going to also have a dense neuron net in there. And those neurons are trained. And so I'll give you an example of that. An LSTM layer, a long-term, short-term memory layer, is what makes models like ChatGPT work. It's really, really good at handling sequential data. So like sentences, one thing after the other. And within that, it's what's called a recurrent network. So it basically takes data and feeds it back around as the input again as it gets its next input, and so it can kind of take everything in context. And So those have their own kind of dense layers, meaning their own neurons within that layer. And so when we're dissecting, we can like see each layer. We can see the neurons that each layer has and the weights of those and the different hyperparameters and whatnot. So if we wanted to, we could do the manual calculations ourselves without running information through the model, just by having those weights and that. So in that sense, we do understand kind of the inner workings and the way that things integrate together. However, it's often not it's not really feasible, and there's often not really enough of a reason to try and separate something else from that mix, because we train models usually for a lot of different tasks at once, so those things are kind of interconnected and have a lot of overlap, and that's actually one of the interesting things that I've been trying to work through in regards to making machine learning models more efficient, is that for every single task that you have like a multimodal model doing or training on, it might not need everything that exists within that model, and yet it's still, all of that is still being trained and run in the same computations as it would for another task that needs all of that.
Okay.
So like if we have, just as a very trivial example, let's say we have 120 neurons in a layer. It's possible that to perform one task accurately, it might only need hey Bobby, the dog just thought she would join us. You want to be on the podcast? She can join us. I don't care. It's possible that one task, if it were trained on its own, might only need a small portion of that 120 neurons, and another task might need all 120 of them. But because you're training them within the same model, the smaller task is still going to use all of those. Mm-hmm. So it's very kind of, in that regard, inefficient. And so when we're training that kind of stuff, and there's no real way to separate that out right now. And so that's kind of one of the things I've been playing around with, trying to optimize. And so hopefully that kind of helps.
Yeah. It's just, I remember there being a lot of mystery kind of about the intelligibility of kind of the really fundamental parts of an AI system. And so I guess that's what I was asking, is kind of where do you think most of the mystery kind of holds within the system?
I'd say the mystery for the majority of the world lies within it, in a lack of understanding of how that stuff works and is calculated. Because once you understand kind of the dynamics of it and what makes it tick, so to speak, it's a lot of the ideas that come out of that mystery surrounding AI, such as, oh, AI is going to take over the world, that kind of thing. That stuff almost becomes laughable, because you understand what it's capable of and what it's not, and how that stuff is even set up, and that it's a whole lot of limitations. And so for the majority of the world, I'd say it would just be in a lack of understanding of the way that AI models are created and designed and the way their interfunctionality works. For us as AI engineers, a lot of the mystery, if I had to say one or two places there's a lot of mystery, it would be hyperparameter tuning, which is like, how do I explain this? It's like little knobs that you can adjust on things that will change the way that the model is trained, like how fast it's trained. Like for instance, one of the parameters is the learning rate, like how fast it learns things.
Is it the more hyper-tuned it is, the quicker you can process?
Well,
information?
the hyperparameters are things like that require, not always, but typically require a person's manual adjustment. So like I decide what the learning rate for the model is. And if it learns too fast, oftentimes it can, skew the data and kind of end up with a really inaccurate, model. If you train it too slow, it takes forever, and can also lead to other problems. And so, the hyperparameter tuning is the tuning of that knob of for things like the learning rate, where you're like, okay, it performs pretty well at this, but it's still training too slow. So I'm gonna try, dialing this back a little bit, making the training a little bit faster, making it kind of pick up on knowledge a little bit more. And so you kind of just like adjust that bit by bit until you find the optimal kind of setting for it.
What do you think is the reason why you need a human exactly to fine tune it? If you couldn't, maybe you could possibly train an AI.
You don't. We have systems that are set up for auto hyperparameter tuning, but a lot of times in experiments, when you're experimenting with something like a new model architecture or something like that, it's more helpful for you to do it yourself, so you can see how that stuff is affecting the model. And there are ways that you can go back and look at the logs later and kind of see, what the results of the auto, tuning, so to speak, were, and gain insight through, that method. But one way or the other, like a human needs to be involved in reviewing, simply for the sake of gaining better understanding of why those are working well, or why certain things aren't working well. And so that is probably one of the more mysterious areas, and it's just because a lot of times the ways that those hyperparameters affect the model are very complicated. It's like, in a sense, it's kind of like calculating the way an acetylcholine synapse firing is going to affect downstream neurons, like your dopamine receptors and or your dopamine neurons, your serotonin neurons, and that kind of stuff. There's a lot of kind of downstream outcropping from that.
That makes sense.
The other area I'd say would probably be primarily lies in our computational limitations, because we can oftentimes imagine architectures or tasks that could be, accomplished, or we imagine could be accomplished a certain way, but lack the hardware and computing power in order to actually test those theories. So that's kind of, as our computing power and our hardware availabilities and capabilities increase, we kind of start getting answers to some of those questions. It's almost like physicists and astrophysicists like making speculations or hypothesizing about something that they're not actually able to verify or prove yet because they don't have the equipment in order to be able to do it. But eventually down the road, those theories and whatnot can be tested as that stuff is either built or it's made more readily available to them.
So a lot of the mystery involves things that we know but aren't verified and tested yet because of our technological inhibition currently, you could say. Potentially.
Yes.
In this area? Okay. Nice.
Or like we suspect a lot of things that we suspect or general ideas that need refinement but have no ability to do it.
Okay. That makes sense. Man, I remember reading this article a while ago about the black box of AI and that there was this sort of binary unintelligibility. So I wondered if there was, if that actually exists or not.
There's not. It's great, makes great clickbait.
They were lying to me. Dang it.
It really depends on how much you want to like delve into it. The word, unintelligible. Most people's brains like would not be well suited for the task of dissecting all of that and like seeing how the mathematics plays out between the data, but it's possible.
Okay.
And who knows, there might be even a kind of more efficient way of dissecting that for the human brain via software, by like breaking down the data as it runs through the model and seeing what effect different neurons have on it. But
I see. Yeah. Okay, that actually clears up a lot because I thought it was a lot like integrated information theory, to where you have the system, but when you take apart the system and you look at kind of like the ones and zeros, really at the fundamental level, you can't really see the intelligibility to where you have this information that represents something within the AI, but doesn't actually translate at all once you take it out of the system. But in the system as a whole, it functions properly. Even with, we understand obviously all the systems, the neurons, everything that's going on, but when you take it apart and look at the binary information, it would potentially be something that's maybe not understandable.
No, it all makes sense.
That makes sense.
If you understand the mathematics behind what's going on. From a observer standpoint, somebody that didn't understand what the underlying kind of structure looked like, it could look unintelligible, I'd imagine.
Okay.
But like, I think
to most people, ones and zeros look pretty
unintelligible. Yeah.
That.
Yeah, I remember the first time seeing audio, an audio wave form in its binary state. I was just like, wow, what? Wow.
Yeah.
What
do those look like? Is it kind of like a
ones and zeros?
But is it just like 1 0 1 0, or is it like 1 0?
Well, typically the way that we deal with audio is not in its binary format. Actually, it's in its array format, where it's like basically an array that contains frequency information. Information about like the each frequency and how loud each frequency is, and
so is it usually more like just normal waves?
It's in a sense, yeah. It's like, well, in numeric sense, yes. Doesn't look like that when you're looking at the numbers, but if you were to plot those numbers out on a graph, which we do all the time. But if you were to pass that to a graph and have it like plot the line
Okay.
for the numbers, yes, that would look like a wave.
Okay. So it's kind of like how we measure kind of the distance or the the distance that a subatomic particle goes. It's kind of like when you put it down, put the mathematics down, you put it, and then it's a wave. You know, kind of similar to
I've
that.
never actually measured the distance that a subatomic particle goes, so I can't say that for sure.
but is it
But
like
like, I assume that sounds like it could be right.
Could be.
Yes.
So, well, I mean, it's just like how you kind of put down the mathematics, you put down the array format, and then
Yeah.
you plug it
Yes.
in.
Yeah.
and it's-
Okay. Yeah. Yeah. I see what you're saying. So it's like yes, it's a time frame sampled data plotting. So yes, you take like a specific time frame and you sample, steps in that time frame, and its velocity or its amplitude, whatever the case is, and then you sample the next time frame and the next time frame and plot that out on a graph.
Okay, that's pretty cool.
So I remember yesterday you mentioned something about the when we were talking about the specific area of neuroscience that you were wanting to specialize in.
Yeah.
What was it that you said it was, the term you used?
Oh yeah. So it's a little bit of a newer branch where it kind of combines psychology and neuroscience. It's
Okay.
cognitive neuropsychology,
Okay.
specifically that.
And what is that typically used for? Like what fields, career paths do people that specialize in that area typically go into?
Well, of course, it's going to borrow a lot. I mean, from there, you literally have 3 different words that have their own respective categories. We have cognitive science, we have neuroscience, and psychology, all in one. So it's kind of taking what we know about consciousness, whatever we know about that, and then neuroscience, and then the behavioral and self aspect of psychology, and adding that all and researching those components and how they interact with each other. So that's mainly what cognitive neuropsychology is.
So your specific interest is in the studying the abstract notions of things like consciousness, or some of these things that we haven't exactly quantified. And is the reason why that's appealing to you because you want to figure out how to define and quantify them, or is it just the topic itself, or like the ambiguity of the topic that's appealing? Or
It's definitely something of a personal resonance with the discipline. So for me, I love the aspect of going through and integrating all of these topics and putting them together to where we do have a sense of the cognitive and the scientific and the psychological aspect of behavior, pretty much, and what that entails and what that means. And I've definitely always been obsessed with purpose. I love purpose and I love value and belief. As a topic, those are fascinating to me because we're belief systems. We're not necessarily like facts. We're not exactly ruled by facts. I mean, if you go down to like a single cell organism, I would say you could say maybe that is oriented by facts, but we're no longer there, right? We've created a meta system to where we have what manifests is a belief system. And through that, you get an extrapolation to where you get a level of competence that you would say is knowledge. And so that's where we get our knowledge. Our knowledge comes and stems from our belief systems, which I have no problem with. It's, we are inherently axiomatic creatures. We're not fundamentally saying this is 100% correct because there's absolutely no way we could know. And maybe this is kind of an evolutionary transitionary stage to where we did kind of have that kind of yes-no fundamental orientation when we were evolving. At this point, we're going through the integrated process to where we don't know enough. We haven't oriented ourselves to the point biologically to where we can start seeing things as fundamentally yes, no, completely, as opposed to kind of this binding of relevant information and then orienting based on what we just think is the best aspect of ourselves. And I guess that's what I really want to dive into, is how we've cognitively developed to get to this systematic understanding of belief as opposed to complete fact and knowledge. How we started at facts and ended at belief. I think that is something that's very fascinating. And from an evolutionary perspective, it's obviously there's that random mutation element. And through that, I would say, yes, that is true, but those who died. And then the relevant information went to the surviving factors and then continued that integrated experience to get to where we have right now, to where they said, yes, this is right, this is wrong. And that, such a small microscopic level, I think that is profound in the sense that it is facts. It's not the type of perceptual belief that we have now. And so understanding the concept of how we evolved to get to fundamental facts leading us to perceptual belief. And I think that's really why I want to go into cognitive neuropsychology, because it really integrates the aspects of those together. And maybe I'll even get a degree in evolutionary biology, because that's something I'm absolutely fascinated in, is the progression throughout.
Genes throughout,
Mhm.
yeah, throughout ancestor, parents to children and whatnot.
Exactly.
Yeah, that's interesting. So lost my train of thought. Going back to what you were saying earlier about about belief being something that stems from our kind of, I guess, an evolutionary extent of our fact-based systems. Define perceptual belief.
So when I say perceptual belief, what I really mean is that we have a model of the world that we live by. And I like to use this, and I like to use these parts of the brain. So from like a moment-to-moment social aspect, we have our ventral medial prefrontal cortex and our temporal parietal junction. And that relationship is the social aspect of our predictions. And so we predict what the socially acceptable thing to do is. And when we come across information that does not align with our beliefs, we change it. And that creates a pretty dramatic shift within the default mode network, which kind of activates your self-referential processing. And the reason why it's relevant is because it goes against your framework.
So for when you use belief here, would it be accurate to term it as your current operating philosophy?
I would say that's a pretty reasonable way to put it.
Like based off of, experience and the current circumstances and what that has taught you, what your current reaction or action should be.
Exactly. It's very much the abstraction of because we're experiential creatures. We're experiential, and we are focused biologically as gene propagation, right? And that's a little different than reproduction. It's more so along the terms of maximally elongated experience for your agent, pretty much.
Elongated experience.
Yeah. So I'm actually developing an ontology, It's called MICE, MEIS, and
Okay.
it's maximally elongated informative experiential success. And I'm using it within a naturalistic framework. It's very much, I wouldn't say it goes along with mainstream physicalism. It's very much taking rudimentary conscious agents as what is fundamental. And I'm playing around with that idea a little bit, you know?
Rudimentary conscious agents. What does that mean?
It would pretty much be equivalent to a excitation of sorts,
Okay.
a fundamental excitation that started the propagation of life.
So, okay. So, an excitation of what?
Still trying to figure that out. I'm doing a lot of research into it. It's hard, but I'm taking that as my axiom currently
Okay.
within the framework is one bounded experience per rudimentary conscious agent. That's the framework that I'm using. And then I'm expanding on that as much as possible until I can get somewhere that actually shows something that I can use empirically to create a decent framework. So this is all just speculation at this point.
Right.
But it's taking different ideas from neuroscience and cognition, cognitive science, and biology and evolutionary biology specifically, and kind of putting them all into one to where we have more so an objective look at the progression of rudimentary systems creating complex ones, as opposed to what we would, really see within perceptions. Because we can get into this topic a little bit, but it's kind of similar as to really my other kind of axiom that I'm taking is that, space time is not fundamental. Our perceptions are not fundamental. They're useful in interfaces with how we interact with fundamental reality. And so I'm taking also that as an axiom to where we say, okay, we're seeing all these things. We're seeing, we've, we've done a lot of research into biology and how it all works. Let's take that information and put it into a framework that is not necessarily a part of what lies within perception, but something as abstract and simple as a excitation and a rudimentary excitation. Instead of saying it's a single cell, we say it's an excitation of sorts. And it's just putting it in a different perspective, a biological progression, organization, and propagation within a framework that allows for a little more of uh, an experiential aspect. It's focusing on successful integrations of an environment rather than gene propagation, because I think gene propagation would be in this framework just a manifestation, not necessarily 100% the purpose, but the main meta purpose that comes from these rudimentary successful integrations. And so I'm playing around with it. We're gonna see how it all goes, and it's very, very simple. Nothing that I think is worth anything at this point,
Right.
but it's so fun. One thing that I really like to do is use the Chat GPT 1.0, the really, really smart one, because it's genius. It really is. It's such a good model. And I'll tell it to critique me as if you like hated this idea and I want you to pinpoint every single one of my flaws and tell me. And so it gave me a really long list of everything that I needed to get through. And it's like, okay, now I'm just going to go through all the points, because those points were really good. I mean, it makes sense as to why he said it. So what I'm doing right now is
So you're saying you gave it a hypothesis or like an assertion.
Yeah, I gave it the ontological framework of mind
and your thoughts on something, and it asked it to basically play devil's advocate.
Yeah, I mean, I have a very much formatted essay on this whole subject, and I'm going to continue it. And
it's good. I mean, it's good to be getting like constant feedback on it.
Yeah, because really, if you can get it to like be brutal, it'll tell you everything that any skeptic would ever say. And that's beautiful. That's exactly what you want.
One of the beautiful things about it being trained off of information from the internet.
I know, exactly. So
did you find the that was that. Did you find that particular model from the Hugging Face that I showed you, Hugging Face website?
Oh, well, it's the new ChatGPT model. So my dad has a subscription to it, so I just kind of logged into his thing. But I'm sure Hugging Face does probably have an even improved version of
Yeah,
of that I might have to look into.
I think I don't know if it was. Yeah, I don't know if it was it 1.0 or was it uh something else. Oh, anyway, there's like a version
That'd be cool.
of Chat GPT that was released on Hugging Face that was like an open source combination of several different models, and it actually performed, in my opinion. I'm not sure. I don't know if I ever looked into the actual statistics, but in my opinion, it performed better than the current Chat
Oh,
GPT.
really?
Yeah.
Oh, just check it out. Check it out at huggingface.co.
No, it's a Spaces on people. Most people wouldn't know how to navigate Hugging Face unless they were AI engineers or had somebody to kind of show them. It's a little bit kind of geared more towards developers.
Yeah, that makes sense.
But I mean, if somebody did feel like exploring that, like they've got a lot of really cool spaces on there that show you some AI models at work. Like you can it's huggingface.co/spaces, and you can browse like some graphical GUI interfaces that people have put together, so you can you can like easily interact with these models and see kind of how they work and whatnot. And there's everything from GPTs to stable diffusion models and
Oh, that's cool. Nice.
yeah.
Okay. So, also, back on the topic of belief and value. I should be careful about how I say belief because what I really mean is what you value. It's more so it's a systematic value system.
So that's actually something I wanted to hit on earlier because in in reinforcement learning, it's a branch of machine learning. For those who don't know, that is based more off of the way that humans, especially as children, learn. You know, involves rewarding actions that are taken that provide the desired results, and then not rewarding actions that don't, and letting it learn through trial and error. And so in reinforcement learning, we have something called a policy, which is something that basically kind of dictates how it's going to pick its action and learn from its mistakes. And it sounds very similar to what you're talking about, where like your current operating philosophy, your current kind of belief, it sounds very similar, where it's like to reinforcement learning policy that like determines the action that you take based off of your past experience of actions taken, and how that relates to your goals, whatever they be. Is that true?
I would say it's very, very similar for sure. One thing that might be actually pretty similar to is this interaction between, so it's called the insula DMN ACC axis interaction, and DMN is default mode network and ACC is the anterior cingulate cortex. And pretty much what this does is it it's synchronized. It synchronizes all these elements when there is a violation of the predicted elements of the situation. And This is true also.
So, in the context, just sorry to interrupt, in the context of outliers, like something that goes awry and leads to an incorrect decision.
Yes.
Okay.
And so when this kind of synchronicity happens, we get a very, very intense self-referential processing action that starts to happen. And it opens up so many new different pathways within your psyche to where you have now the ability to truly and consciously change your fundamental values. And when these fundamental physiological values are changed, then it shifts perception. And when it shifts perception, all it does is it changes what is the most relevant information in your surroundings, in the model of the world. And so that's why, very interesting, if you drive an RV, you are going to see a lot more RVs on the road than if you didn't. Same if you drive a red car. What you value is going to change what you see in the world. And it's not like you could value something that's outside of developed perceptions per se. I mean, it's possible, perhaps. Maybe there is some sort of value that we could create that would change drastically what we see to where out of the 9 bits of information we take in every second, the 20 that we actually consciously receive would be something that nobody is focused on, which is why I think there's certain levels of genius that are not necessarily be able to be recreated, because what relevant information they're focused on is something that is far beyond your reach. You don't know how to believe in what they do because it's a little more intrinsic and something that they found personally from their subjective experience, and isn't explained within like, oh, this is how you do it. It's a manifestation of something very particular, and it's more of a conscious feeling as opposed to something that's like a practice.
There's a part of 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 what you're describing um, that makes a lot of sense, because it sounds a lot like feature extraction, where as data is input into the system, you have a system of networks that is set up, designed to extract features from that data that are important, and then feed that through its, that kind of filtered data through its processing. And in that regard, I could see how that could be the case, if somebody's feature extractors, like in machine learning, um, we often refer to these as like as encoders and decoders or autoencoders, but like these, as that information is encoded, if somebody's network that is encoding that information is slightly different from most people's network that's encoding that information, it could tune them into different portions of the data that wouldn't normally be processed by most people.
Yeah.
And that could lead to, some sort of savant, in a specific topic, just because your senses were tuned slightly different than most people's.
Yeah.
And so that is really interesting. I'm not quite sure. I'm not quite sure I followed all of the relevance beyond the feature extraction, but the and the feeding into the network, you know, that way. But that it does bring up a really interesting question of if we were able to almost like hyperparameter tuning, like if we were able to kind of tune our inputs to various, you know, attenuations to the data we were receiving, could that lead to possibly revelations that we wouldn't have
Oh yeah.
reached otherwise?
Dan Siegel and Bessel van der Kolk actually did some really interesting research into that, where it's that revelation aspect. And it's that feeling of revelation and deep insight that is very much self-referential, and it's very much extrapolating every relevant feature and practically putting it right in front of you. And then you having the ability to then, now that you are exposed, practically the essence of your being is exposed through that revelation. From there, you then have the choice to then, if it looks good enough, if it's something that will be useful, you can then implement the new integrated information back into yourself. And that's really what characterizes those profound moments of insight, those spiritual experiences, is that actualization of everything you are, and then the ability to then take in the new information and change that value, and then look at the world from a new perspective. And that perspective comes with different relevant information, and things will obviously still look similar. I mean, it's it's very intricate, right? It's not like this chair is going to look like a table based on my values, right? It's more so a perceptual change based on, relevant information, and
It's part of the sensory data that you're tuning into and focusing on.
Yeah. Exactly. And a lot of that is within the default mode network, and probably a lot of it is very visual, even potentially, because I mean, what we see is, what we think is, we look at, what's most relevant. I mean, when you look at somebody, and you see their eyes go somewhere else, you're not like, oh, that was just random. It's like, oh no, they're looking at something relevant. Like, this is a relevant insight that, from their perspective, are they attending. So maybe that means I should also attend to that perspective as well.
This is a little bit of a random thought, but well, not random, but a little bit of break. I wonder, how like when you're focused on something, everything else in your vision, on the sides of your vision, seems to kind of like blur out, and it's just the thing that you're focused on that's kind of crisp and clear. I wonder how much of that blurring is done in the brain. Like, once the data is already taken in from the eyes and transmitted to the brain, if that's a part of the feature extraction process to blur the parts of the data it doesn't need.
I would say so.
Or I wonder, like, because I'm sure part of it has to do with the eyes focusing mechanisms, like, but I wonder if there's like also a part of that that's done by the kind of feature extraction, because you can choose to like, tune into other parts of the data if you want to.
Would it be right in saying that if there's a feature extraction, there could be a feature inhibition, potentially?
Well, it's kind of what feature extraction kind of encompasses.
Okay.
Feature inhibition. It's feature inhibition and enhancement. So like chooses what features are important, what ones aren't, and kind of either completely gets rid of or minimizes the features that aren't important.
Okay. Yeah. That makes sense. So I guess it would be it would be very difficult to survive if you really were trying to focus, and all of a sudden this side was just completely visual, and like all of the relevant information was
Right.
making this wall in my peripheral vision really crisp, I don't even think it would have, if I were to focus my retinas on you, I don't think it would even have the relevant information to do that in the first place. Probably. It probably is taking in as much as it can. And it's,
Yeah, but there's probably also an element of like computing power that your brain, when it's really tuned into something, like it's focusing on processing this stuff coming in from a specific source.
yeah. I mean,
And so it's like really, really like working on that. Like for instance, when I'm focused on you, like I'm really tuned in to your data, like specifically, and everything else kind of, you know, is going to take a back seat, so to speak. And but if you're boring me, I could be probably taking in a lot of other data at the same time, and you know, be processing it fine, you know. But I think it's the element of your brain's processing being dedicated to a specific feature of the data that it's getting, that maybe kind of causes a lot of that and needing the computing power for it.
yeah. Oh, yeah, for sure. I would definitely say that focus and inhibition of all other information is definitely something that takes more computational power than to let it all go free.
Yeah, and that actually brings up interesting points, like with kind of one of our overlapping passions or interests, which is in neuroreceptors and neurochemicals. How you have inhibitory and excitatory neurochemical, like dopamine. A lot of it's inhibitory. Like people think of dopamine as exciting.
Yeah, it's like
And
manic.
something that's like this, like, oh yeah, you know, super excited for this. But a lot of it's actually inhibitory, meaning it calms down areas of your brain, and it does that so that the areas that need the resources and the power and that need to be used more can.
Yeah, yeah. It's very interesting that you bring that up because the psychological literature shows that people with, you know, mania or who have like manic episodes like constantly are, you know, it's an intense amount of dopamine, like way, it's like just waves of dopamine after another. And they're always talking about doing different things, you know, becoming millionaires, you know, buying all of these incredible things. But they don't. They never do it. They just are in an excited state of wanting something, but never actually actualize that in
It's like
real life.
somebody snorting cocaine or something.
Yeah, but it's that level of dopamine is inhibiting them from actually achieving any sort of goal whatsoever in their life. So it's
Yeah, well, I feel like that's actually almost a different sort of inhibition,
yeah,
because
I guess so.
it's like, and it still is inhibition, but it's more of uh, a action based inhibition as a result of overstimulation. Like there are too many things that are going on, and I can't pick any of them.
Yeah.
You know, kind of a thing. There's a certain level of inhibition and excitation, like a ratio that like becomes
Yeah.
really good for focusing and for tuning into stuff and for you know, pursuing things that you're passionate about. And but when you don't have that ratio going on, and it just is like you bring all levels up, you know, at the same time, or all levels down, you get really unproductive states like what you're talking about, where now I'm so excited about everything that I can't decide which of these exciting things I want to do. And you know, the opposite side of that, which is I know I should be doing things right now, but I can't decide which one I'm least excited about. Like,
Yeah.
um, and so when those ratios become wonky, like you don't have something specific that is being stimulated, and then everything else, allowing everything else to kind of like drop away. That I think probably kind of can turn what should be a really positive thing into something that's really unproductive.
Yeah. And I've always found it interesting, the relationship between dopamine and courage. And
What's that quote? Courage is by far the kindest word for stupidity.
exactly. And a lot of that really does have to do with dopamine. I mean, let's say, you go into the forest and there is just a bear right there. If you had no dopamine response from that, you are not going to have I don't know if it's exactly the best example, but practically speaking, you're not going to have the courage to do anything about the situation at all if there was no intense dopaminergic response. It's that dopamine that gives you that drive to achieve your goals, and it allows you to then, make the correct decision to run away, or if you have a gun, shoot at the bear. It's that dopamine that allows you to then transition into that kind of fight or flight mode.
Isn't that more neoadrenaline?
Yes, it is that too, but without the dopamine, I don't think the noradrenaline would get triggered at all.
That's interesting.
Or maybe it's
I'll have to look into that.
maybe it's both. I just know in that context, adrenaline would be that helpful response, as opposed to dopamine being the kind of more the thinker, kind of the person who's kind of.
It would be interesting to look into which neurochemical typically prompts the other, if it's adrenaline that prompts dopamine, or if it's dopamine that prompts adrenaline. If I had to guess at it, I'd say I'd imagine like the adrenaline would prompt dopamine, because adrenaline is a more immediate and necessary, like neurochemical. Not that the others aren't necessary, but like it's a more primal, like neurochemical. It's the one that is going to
Adrenaline?
Is going to what?
Adrenaline? Okay.
It's the one that's going to. That's what I said, isn't it?
Yeah. I was like, oh, so that's a little more primal. And
it's the one that's going to give you fast reaction times, and it's going to let you be on edge, and kind of that give you that jittery feeling, like anything could happen right now, and the dopamine, I feel like oftentimes probably stems from the idea of overcoming whatever it is that has sent you into adrenaline mode.
Yeah.
And the desire to kind of beat it and, be victorious, or it's probably why, after a life-threatening experience, you typically feel really good.
Yeah.
You're like, oh, I'm alive. I did it.
And we call those people adrenaline junkies also. What I would probably say that dopamine is what allows you to move in such an excited state. That's probably what dopamine does. And so it kind of,
well, it probably allows you to give a response that is more logical, like more calculated, like than you would otherwise. Because I feel like adrenaline on its own would probably just mainly lead to a flight response.
Yeah.
Like,
it depends on your goals.
well, like if there's something,
If it's a bear, I'm running.
if something is life threatening, like, and you just have adrenaline that sends you into the oh my god like state, I feel like you'd probably one goal would be to get yourself as far away from the situation as possible.
Mm-hmm.
So fleeing. Be interesting to know if dopamine is actually what enables the fight response to that, the one that wants to overcome. I could see that like playing a major role in the motivation to actually possibly face it head on.
Yeah. Which is where we get that kind of courage aspect. And so, and I find that relationship on many different levels. It doesn't have to always be in a life or death situation, but the courage to face different fears, whether that's personal fears that you have, or psychological fears that you have with yourself, or a fear of a person or of a social dynamic, different things of that sorts, to where if you were to not base your dopamine responses on the most relevant information to conquering your goals, you would have a decrease in the ability to have the courage to face your fears. So, and this might be relevant too when we were talking about, like how dopamine affects scrolling, through social media. And while it doesn't decrease dopamine responses overall, it might affect the relevant dopaminergic responses, what excites your dopamine. And so if you have all your dopamine going to, let's say, things of a pleasurable nature instead of a courageous nature, and facing the unknown, you would have you would not be able to have the courage in any way, shape, or form to face the things that you need to live a better life because of your focus on how you use your dopamine.
So you're saying it stimulates you to unproductive areas.
Yeah. And so while the amount of dopamine you have in your brain would not decrease, you just wouldn't get a response or it'd be very unlikely for you to actually want to, it wouldn't feel good to think about such a thing as overcoming that.
Which is why would you go through the difficulty of facing a hard, circumstance in life, something that's difficult to overcome, takes a lot of effort, a lot of work. Why would you go through that trouble when you could get stimulation from, scrolling on your phone?
Yeah, exactly. And that's definitely something that has really bothered me for a really long time, is that we have a whole culture that, lives their life not in like, obviously there's a lot of suffering going on in the world, but when we like to sit back, relax, what are we going to do? We're going to read a book. Are we going to watch a full-length movie or a TV show? Probably not. Sometimes, yes. But the majority of people are going to scroll on their phones. And when we are people that base their entire physiological orientation on beliefs and value, you have a situation to where you are living your life scrolling through an insane amount of information and different ideas by different people, and you don't exactly know what's going to come next. You can't form a coherent story. The pleasure that you get is not the autobiographical story that is needed for you to continue growth, but rather immature, vague ideas constantly being scrolled, where you get your dopamine response, you get your values, you get most of your things from 10-second clips. That's what our culture is practically built on. And it's terrifying.
We sound like old men right now.
These kids nowadays
scrolling on their phones.
No, but the reason why I'm so passionate about it, because that was me. That was me. When I was younger, all I would do was go to the gym and scroll on reels. My entire, like, for 6 months, that's practically all I did. And
Well, you forgot that you got to take a selfie to let them know you're at the gym.
exactly. And I also had a fitness account as well. So, I got my external validation that I need.
Yes, I mean, what guy doesn't have a fitness account?
Exactly. Yeah, I had a couple of videos that did pretty good too. Yeah, so I remember 2 of them got to like 80,000 likes. I was like, yeah, that was, dude, that, when I tell you I had,
that cool.
yeah, when I tell you that made my brain happy. Yeah.
You got them dopamines.
No, dude, that dopamine rush when the likes started pulling in. Oof. And that's also very dangerous as to if one of your videos goes viral, oh man, dude,
That's all you're doing for the rest of your life.
Yeah, you don't want anything else besides the constant external validation of that many people.
I imagine that's a lot like what artists, musicians deal with whenever they get a song on the top 100 or something like that. They kind of climb a little higher on the popularity axis, and so they reach top 10. Well, now if they release an album that doesn't have a song on the top 10, that's not good enough.
Yeah.
And in fact, they don't just want the top 10 now. They want to be 9th or 8th or 7th, and that's one of the reasons why I love finding my, kind of going back to what previous topics are, our core or our value, kind of policies for where we find value, and where I, gain reward and stimulation from. It's one of the reasons why I love getting stimulated by like new information and new knowledge, which probably to some people sounds really boring, but like learning new topics that opens up new worlds of like possibility and new understandings into other things that kind of connect with it, or maybe don't directly connect with it, but brings new ideas forward, and fires kind of the imagination. Like getting reward from that is so much more sustainable in a long-term setting, because like for instance, just in my field in machine learning, like the skill ceiling is so high. Like there's always more to learn. There's always more to do. Like you can you can study till you drop dead, like, and there's still going to be more to do in the field of AI and machine learning. So it's an endless field, and that like sets you up for a future of like being able to find reward through the pursuit of knowledge. And it just doesn't have to be specific to your field. It can be with anything. Like I love learning about physics and astrophysics and biology and neuroscience and all that stuff. And so I think if people were to condition their brains more often to be stimulated by things long term that last, provide more levels of pursuit, then I think that they would end up a lot happier in the long term.
Yeah. I like to say that the mind doesn't create matter, it creates what matters. And you have the ability to change always. And what's very interesting is that there is some research done by I'm pretty sure it's a psychologist, Peter Levin, who saw that if you avoid yourself, you are very unlikely to change. You never will. If you reach the lowest point of your life and you don't allow that self-referential processing to happen, you develop you compensate that by inhibiting your default mode network directly, and you don't allow that self-referential processing to happen. And that's so interesting that if you can inhibit it, who's to say you can't realize it even more intensely on a daily basis, to where you have the ability to then take in this knowledge that is now a part of you, and to bring that back out and reshape it in a way that is better for you and for your understanding that, and that leads to new questions. And
Well, how would you ever expect to be able to improve if you don't have a solid, like understanding and, reference for yourself? Like, who are you? What is your current state? What are like the reasons why you do the things that you do, and like the motivations behind things for you? If you never delve into that, you don't really have the ability to modify yourself on anything but a very superficial level. It's only through exploring those depths, exploring the internals of the AI model, like, understanding the inner workings and how everything plays out, that you can really tune yourself to perform how you want to perform. Well, guys, I think that's a good stopping place.
good place to start.
Yeah. Stop starting. Yeah.
Perfect.
Dude, I'm telling you, time flies by when we're talking.
I could do this for another 2 hours.
I wouldn't have noticed, like, if it weren't for my stomach that was like telling me what time it was, I wouldn't have noticed.
Time to eat. That's
Well,
fair.
thank you guys for tuning in. Again, this is a little bit of an experiment. We're testing out sound levels. We're testing out, video settings and whatnot. And so it may look a little bit different next time, but we'll keep on refining, and hopefully we'll have a solid regular format for you guys coming out here.
Oh, yeah. All right.
Thanks for joining us.
Peace out.